In the vastness of the universe, black holes are like a mysterious and terrifying beast. Its gravitational pull is extremely powerful, like an invincible trap in the universe, able to mercilessly devour everything that comes close to its orbit. Even the light that is extremely fast cannot escape its clutches. The existence of black holes is like a scientific chasm that is difficult to cross. It completely subverted the traditional understanding of physics, become the most challenging and mysterious object of study in the field of astronomy. The discovery of black holes has been long and full of twists and turns. Year 1783. Brilliant physicist of United Kingdom, John Michell. In the persistent search for an effective way to determine the mass of a star, with Newtonian mechanics and the particle theory of light, I was surprised to notice a strange phenomenon. He was acutely acute. The velocity at which light particles leave the surface of the star can be significantly affected by the gravitational pull of the star, and this speed depends on the size and mass of the star. Carefully calculated, he came to a startling conclusion. When the mass of a star is equivalent to 500 suns, light particles will not be able to escape the gravitational pull of the star. Such stars are invisible. The only way to do this is by detecting its gravitational effect on surrounding objects, to be able to be discovered. Michell named this invisible star a dark star. It was the precursor to the black hole as we know it today. Yet in those times, Michell's forward-thinking concept is too shocking. Failure to get the attention it deserves. Fast forward to 1915. Karl Schwarzschild, the preeminent astronomer of Germany, based on the gravitational field equation from Einstein's general theory of relativity, successfully calculated the gravitational limit of a celestial body. He asserted, when a supermassive star is nearing the end of its life, the huge gravitational pull will cause the surrounding spacetime to continue to collapse. Hard body density is increasing. Ultimately, the space will have an infinite zone rate, evolve into an inescapable point. Schwarzschild calculates the matter in the curved space, pleasantly surprised to discover the key boundary. Once the substance crosses this boundary, it will disappear completely, and this limit space formed by the aggregation and drag of matter. It is the mysterious black hole. To confirm the real existence of black holes, the key is to look for gravitational waves. Einstein based on the phenomenon of space-time curvature in the general theory of relativity. After in-depth derivation of the gravitational field equation, it is believed that it is highly likely that there will be varying degrees of disturbance in space-time, and these perturbations will propagate rapidly in the form of waves through the universe. When two massive objects like black holes meet, and in the event of a violent collision, the energy generated will be up to dozens of times that of the entire visible universe. At the same time, powerful gravitational waves burst out, expanding to the entire universe at the speed of light. September 13, 2015. Humans have successfully recorded it. In LIBO from a billion light-years away. This strange sound. Not only does it become conclusive evidence that black holes really exist, it also strongly confirms Einstein's accurate prediction of EM LIBO. The EM LIBO is produced by the merger of black holes with 29 and 36 solar masses. Post-merger, the mass of the black hole is about 62 times the mass of the Sun. The remaining 3 times are released in the form of EM LIBO. EM LIBO has been expanding at the speed of light since the time the Earth symbolizes life. After a long billion years, travel through the vastness of the Milky Way, skip the planets and eventually reach Earth. April 2017. 8 radio telescopes around the world. Joint observation of the same target source. They record a lot of data. A virtual telescope with an aperture equal to the diameter of the Earth is formed. Next, take advantage of extra-long baselines, interferometry techniques to reconstruct the data. Since each telescope is at a different distance from the black hole, recorded electromagnetic wave signals, light and dark stripes of varying thickness are formed. To reduce timing errors, a time alignment device in the atom is also used. After huge and complex calculations, humanity finally got it. The first ever image of a black hole. But the mechanism by which black holes form remains a mystery to this day. Perhaps there really is a completely closed world inside. Only with the deeper study of black holes, the mysterious secrets contained in them will gradually be revealed.